Maple for calculus. This is lesson 4. So let me start by defining a function in Maple. So it doesn't matter what letter you want to use to denote the function, or what word, or what variable you want. But if you want to define, for example, the function f of x equal x squared, we write f and then colon equal. Colon equal is the assignment operator in Maple. It assigns a value to a variable. In this case, the variable is f, which is going to be the function. And if you want this to be the function that sends x to x squared, we write x, and then we want an arrow. And the way you get an arrow is the minus sign followed by shift period, the greater than sign. And this appears on your screen as an arrow. And let's say x squared. So I've defined the function f of x equal x squared. Let's see. F of x is x squared. F of 3 is 3 squared, which is 9. F of 87.2193 should be a decimal point. That's what it is. So let me just make the following remark. You get the arrow by typing a minus sign followed with no space by the greater than sign. Okay, that's how we get this arrow. So now we have a function. If we want to plot it, we just write plot f of x, comma x. And that's the plot of our parabola. If we want to define a new function, let's say g, maybe I'll call the variable t. Say this is t cubed minus 9 t squared plus t plus 11 over, I don't know, t squared minus 5t plus 4 times, I don't know, t squared minus 6. That's some function. If we want to evaluate it as some number like, I don't know, 0, we get the value of the function at 0. If we want to plot g of t, that's what we get. And this is actually very interesting because there's certain places where this function's not defined, namely where the derivative is 0. And where the derivative is 0 and the numerator is not 0, we get a vertical asymptote. Suppose we want to find the places where the derivative is 0. So this is the problem of determine the vertical asymptotes of this function. And the way we do that is we solve for the places where the denominator is 0. Solve this with respect to t. So we get 4 places where the denominator is 0, 1, 4 minus root 6 and plus root 6. EVALF converts a number to a decimal. Percent means plug in the last things you calculated. The last things we calculated were these 4 numbers. And here are these 4 numbers as decimals. Let's see, let's look at this. Let me graph this maybe just from -5 to 5 so I can see more clearly the vertical asymptotes. T equals -5 ... 5. Okay. So here you see there's a vertical asymptote at 4, a vertical asymptote at, this is about 2.44. This is a vertical asymptote at 1, and this is the vertical asymptote at -2.44. So you can tell by plotting your function in Maple where your function has a vertical asymptote. That is certainly a useful thing to know. Let me just make one other remark. Here I solved this equation explicitly. It turned out, because they were just quadratics, there was an explicit solution that Maple could write down. If I wanted to solve it immediately in decimals, I would use the command fsolve instead of solve. And then I get exactly the solution in decimals. All right, at this point, Maple chooses to write 1 as 1 point a lot of zeros, but that's not important. So the important thing here to remember is how to define a function. And we see how to plot a function and to solve some equations. We have 2 commands for dealing with polynomials. One is factor, and the other is expand. So if we have a polynomial like, say, a product of polynomials, well, here's a polynomial. If we want to factor it, the command is factor. Well, looks like this polynomial doesn't factor at all. I mean, if Maple doesn't factor it, it can't be factored. Suppose I have this polynomial. That does factor. Maple factored it. I mean, here's a polynomial. It's hard to figure out by looking whether or not this factors. Let's see. Let me give the command to factor it. It does factor. This is a polynomial of degree 5, and it factors into a polynomial of degree 1 and a polynomial of degree 4. Suppose we have a product of polynomials. Let's just take a couple of these. So here's a product of 3 polynomials. To multiply it together or expand it, we use the command expand. Oops, put everything inside parentheses. So you can tell this is going to be a polynomial of degree 10 because you have degree 2 times degree 5 times degree 3, and 2 plus 5 plus 3 is 10. And when you expand it, this is what you get. If you want to factor it, see whether you get back what you started with. Well, you didn't get this back. Why not? Because when you factor this, Maple factors completely. And some of these were not irreducible. So we actually have 1, 2, 3, 4, 5, 6 different factors that come up when you factor this polynomial. Now, if you're interested in integers, so you should have learned somewhere along the way that every positive integer is a product of prime numbers. A prime number is a number that can't be factored as a product of 2 strictly smaller numbers. And there's a command to factor an integer, and it is I factor, I-F-A-C-T-O-R. And if you want to factor 6, for example, I factor 6, it's 2 times 3. If you want to I factor 720, this means 2 to the 4th, 3 squared times 5. So when you factor this integer, there are 3 different primes that divide 720, 2, 3, and 5. But when you write 720 as a product of primes, it's 2 times 2 times 2 times 2, 3 times 3 times 3, and 5. This is the prime factorization. If you want to check, let's multiply this together. I always like to put in my times signs. Yeah, when you multiply this together, you get 720. You want to factor 721, that turns out to be 7 times 103. Factor 723, that turns out to be 3 times 241. You want to factor 727. You get 727. What does that mean? It means that 727 is a prime number. You can't break it down as a product of smaller numbers. Suppose you want to solve the following problem. Factor all integers from 1 to 100. So you could start going lowercase. I factor 1, I factor 2, I factor 3, I factor 4, four is 2 times. You could do this 100 times, but you really don't want to. So there is something that in Maple and in most computer programs, most computer languages, that allow you to repeat something as many times as you need to. It's something called a loop. So this is now very important. How to construct a loop. It's sometimes called a do loop, because we're going to ask Maple to do something. And in this case, what we want to do is factor all the integers from 1 to 100. So there is this very particular syntax in Maple for doing this. And it uses what are called certain words that have very specific meanings in Maple. The first is the word for. And you notice it appears in boldface. A reserved word in Maple will show up in boldface. And what we want to do is factor every integer n from 1 to 100. So for n from 1 to 100 do. So you notice the words in boldface are for, from, to, and do. So, and now I want to move my cursor down a line. If I just press enter, I get, it says error, invalid loop, because this isn't complete. So, but the way you move down a line is not to hit enter, is to do shift and then enter. And now I've moved down a line. Let me indent so I know exactly what I want to do. I want to I factor the number n. And then I shift down a line. And that's all I wanted to do. So this is the end of my loop. And I give the command n do, which is also in boldface. Maybe just so I don't get a lot of printout right away, let me just do this for 1 to 5. So I'm asking, so this is the command for n from 1 to 5 do what? Factor n, I factor n do. I hit enter, and here I get the factorizations of 1, 2, 3, 4, and 5. If I really want to go up to 100, let me just change this to 100. Here it is. This is the factorization of all the numbers up to 100. Of course, if I look at a number, I don't know exactly what number it is. So what I'm going to do is just change this little program slightly. I'm going to do what? Type n and comma, and then the factorization of n. So now, here's the output of this little computer program. I have all the numbers from 1 to 100. Okay? Like here is 87. And the factorization is 3 times 29. 88 is 2 cubed times 11. 89 is 89. That's because 89 is a prime. 90 is 2 times 3 squared times 5, and so on. Okay. So this is our first example of a loop, and it's a very important thing in a computer program to be able to have the ability to compute loops. This made a loop. Suppose we want to factor the numbers of the polynomials. Suppose we want polynomials of the form x cubed minus n. For n from 1 to, I don't know, 30. So how can I write a loop for that? I would say for n from 1 to 30 do. And then shift enter, shift enter. I never want to forget my n do. Let me go back up now. And what I want to do is factor the polynomial x cubed minus n. So it seems most of these can't be factored at all. Just so this is n equal 1. This is x cubed minus 1. Let me see if I can do something else. Let me write x cubed minus n equals. Let me see if this works. Aha, perfect. So x cubed minus 1 factors. These don't. This one does. Yeah. Let me make it more interesting. Maybe x squared minus n, or minus x minus n. Huh. Yeah. A few of them factor, but not most of them. Let's go back and to something else we did in a previous lesson, limits. So limits, there's a command called limit and has two versions. One is spelled with a lowercase l and the other spelled with an uppercase L. So if you write limit, let's take something we know, sine of t, that's how you write sine of t, divided by t. As t goes to 0, we get the number 1. If we write limit with a capital L, we just get a restatement of the problem. And one nice thing you can do in Maple is put these together. So you actually see the output as an equation. The limit as t goes to 0, sine t over t is 1. Let's make it more interesting. Suppose this were 3 times t over 7 times t. This turns out to be 3/7. Suppose this is sine 3t over the cosine of t. That turns out to be 0. Suppose we had suppose I have this rational function. This says the limit is -9. Now, this is a little tricky. Oh, sorry, x equals 0. I want to make this, that's perfectly okay. But I want to find the limit as x goes to 3. 27/2. Now, see, this is a little bit more interesting because if you try to plug in x equals 3, you will get 0/0. So this tells us this limit is 27/2. Let's check by graphing this function. Suppose I plot this. So this says that there is a vertical asymptote here, but at x equals 3, it has the value 13.5. Why is that? Because you can factor the denominator. So this denominator is 0 at 1 and at 3. At 1, you have a vertical asymptote, but not at 3. That's because it has to be that this also factors. Let's just factor the numerator. Yeah. So when you look at the quotient, the x minus 3 is factor. Let's try something. There's a command in Maple called simplify. Let's see what happens if we try to simplify this. Fantastic. So what Maple does with this command simplify, you never know what it's going to do, it's just something to try every now and then, is when you simplify it, it factors the numerator and the denominator, it cancels the x minus 3's, so you get x squared plus 3x plus 9 divided by x minus 1. And now you can see exactly why you have a vertical asymptote at x equals 1, but you have a removable discontinuity at x equals 3. Yeah. And you can use a loop to find lots of different things. Suppose you want to compute the limit of sine of mt. Oops, I don't want to do that. divided by 2mt for m from 1 to 10 as t goes to 0. So what we're trying to get is the limit of sine of 2m times t divided by m times t as t goes to 0. But I want to do it 10 times, and I don't want to have to write 10 different equations down. So let me do Shift Enter and make this a loop for m from 1 to 10 do. And what I want to do is then end the do. And I misspelled from, so I need to make this spelled correctly. Looks like the answer is always 2. Let me write it like this so I see some equations. Oops. Here we go. So I have all these limits, and they all turn out to equal 2. And what's very pretty is, well, I didn't have to do it 10 times. I mean, I could have done it as many times as I wanted. I could do it 20 times. There we are. Maple doesn't care. Just doesn't. So a loop is a very powerful programming technique. And now you know how to write a loop in Maple, which is very good. Okay. That is all for lesson